Good afternoon, my YouTube viewers. It is Crystal here, and I'm here because I want to give you another code review. So I've been working the past couple of days on something, and basically I was working on a really hard data set, but I couldn't find a data set that I wanted to use because this really hard data set that I was working on was on the TensorFloe site, and I didn't mind copying the code into my Google Colab Jupyter notebook for my own study, but I wasn't too keen on doing a code review and making a blog post on it because it wasn't really my work. It was TensorFlow's work, and so I thought, well, I only want to do code reviews on my work, and I only want to do blog posts on my work. So I looked for another data set that I could find, and there are so many data sets to go through that I picked a forest fire data set. And then so this forest fire data set, I still wasn't able to use the techniques in that TensorFlow page that I was using, except I was able to use one hot encoding, and I was able to use a little bit of train test split. And so I thought, okay, well, I'll do that. So it's my work, but I did use the work from TensorFlow because obviously I'm still learning TensorFlow. And since I'm still learning TensorFlow, I'm trying to learn their techniques, and I'm trying to learn how they do it. So that's what this code is going to be about. So I created the Jupyter Notebook in Google Colab, and Google Colab is a good platform to use, but it doesn't have a very good undo function. So you need to be very careful that you don't accidentally delete or overwrite data. If you do delete or overwrite data, there's a possibility that you can go into the saved. You can go into saved right here and then look in a previous edition and then maybe get the code from the previous edition. So I've done that before. I've been able to get the code by looking in the save history. So there's a possibility, it's no guarantee, but there's a possibility that you can do that. So after we created our program, what we want to do is we want to import the libraries. And the way I do it is I import all the libraries that I know I'm going to use at the very beginning, but when I get to TensorFlow and sklearn, I import those libraries as I need them. So we're going to import NumPy as NP, which is your numerical computations. We're going to import pandas as PD, which is your data processing. We're going to import Seaborn as SNS, which is visualization with statistics. And we're going to import matplot.pyplot as PLT, which is visualization as well. We're also going to import sklearn, which is your machine learning functionality, and we're going to import TensorFlow, which is your neural network and your deep learning. So after we have imported our libraries, then what we're going to do is we're going to load our data set. So I did get this data set from the TensorFlow data sets, and I was able to find it, and I was able to get it as a CSV file. And so we took pandas and we converted the CSV file into a data frame. So this is your data frame with X, Y coordinates, month, day, FFMC, DMC, DC, ISI, temperature, RH, wind, rain, and area. So I'm assuming that area is the label or the target, and it talks about the area that the forest fire enveloped. So we're going to check the And we have the shape of the data frame, which is 517 rows by 13 columns, and we're going to check the size, which is 6,721 cells, because you take 517 and multiply that by 13. We describe it. So when we describe it, you get your count, you get your mean, standard deviation, min, 25%, 50%, 75%, and max. And now what we did is we did a for loop so we could find all of the unique values in the for loop. So the first thing I did was I wanted to check was the number of unique values. And then next thing that I did, I said, was if the unique values are less than 13, print them out. If the number of unique values are less than 13, then print them out. So you can see all of the numbers of unique values and the unique values that are less than 13. We check for any null characters. There's no null characters, so that's good. That means that I didn't have anything to impute. Didn't have to deal with any null characters. Now we define our target. Data frame target equals data frame area, and then we just drop area from the data frame. And we've got our disk plot. We created a disk plot, which I should have done this. I didn't do it. I was in a bit of a hurry. I should have done that, and then that will give you a little loop and tell you how about the distribution that it makes. I did a value counts to see if there were any examples where the number appeared only once, and there were quite a few examples where the number appeared only once. So what I did was I filtered that out. So I filtered it out and selected only those examples where the example appears more than once. And then so we do that again. You can see it looks pretty close. This means KDE equals kernel density estimate. And I didn't do that, so it just puts a little bitty line on the chart to tell you that the line that it makes. So what I did was I created a box plot so you can see the day of the week where you've got most fires, and it looks like Saturday is the day of the week where you've got most fires. And then I created another box plot to tell you about the month where you have the most fires. And it looks like September is the month that you have the most fires, followed by August. So now we did a scatter plot on the temperature. So the temperature will tell you about the fire. So it looks like as the temperature increases, you're going to get more fires. And we're going to check the wind. And so it gives you the wind pattern, tells you about the fires. And then we also checked the rain. So if you know how to read scatter plots. Now what we've done is we've done our one hot encoding, because that seems to be what TensorFloe wants to use. TensorFloe doesn't really want to use ordinal encoding. They want to use one hot encoding. I'm not quite sure if it makes a difference whether you use one hot encoding or ordinal encoding, but ordinal encoding is when the values have a rank, and one hot encoding is when they don't. So I went ahead and did one hot encoding because that's kind of like the way they do things in TensorFloe, and so I wanted to do things the TensorFloe way, so that's what I did. Now what we did was we used sklearn. Oh, and then the one hot encoding, that's pandas. if you see here, it's the one hot encoding is pandas. So now what we did is we're using sklearn to split the data set. The first thing that we do is train test split data frame, test size equals 1.1. And then we do train val equals train test split train, and then the test size is 0.1. So now we've split this out into 3 data frames. So you've got the train data frame, the val data frame, and the test data frame. So you can check train, val, and test. And then so now what we do is now we've got our train, val, and test data frames. What we're going to do is we're going to create train features, val features, and test features. And train labels, val labels, and test labels is when you just pop out the target, and that's the code. That is a Python inbuilt function, which I normally always had used drop, but with Python, because it's a Python function, you pop it out. And that is, again, the way TensorFlow does it. This is part of TensorFlow speak, is where you pop it out. So since I wanted to do it the way TensorFlow does it, I had to do TensorFlow speak. So now what we're going to do is we're going to normalize the data. So train.describe, transpose mean and standard. So that means that you only want to see the mean and you only want to see the standard deviation. So now we're going to get in to where we're actually using TensorFlow functions. And the first function that we're going to be using is the normalizer function. So normalizer equals tf.keras.layers normalization axis equals -1. Normalizer.adapt NP array train features, so they're using train features. Print normalizer mean numpy, so that's telling you the means of I'm supposing it's the 30 columns. And then now we use it. We say first equals np.array train features, and it's the first example of the first row with np.print options. Precision equals 2, suppress equals true. Print first example first, print normalized, normalizer first numpy. So you can see the first example, what the values in the first example are, and you can see what the values of the first example are after they've been normalized. And now what we're going to do is we're going to create our model, which is a sequential model. So def, build, and compile model, which norm, so that's to take in the normalized data. Model equals keras.sequential. Norm is your first layer, and that's taking in the normalized data. Layers.dense 128 activation equals ReLU. Layers.dense 64 activation equals ReLU. Layers.dense 64 activation equals ReLU. And layers.dense 1, because it has only one output. We compile it. Loss equals mean absolute error. Optimizer equals TF keras optimizers. Atom learning rate is 0.001. And then we return the model. So model equals build and compile model normalizer. So it's going to be, you're going to take in the normalized data. And then we check our model summary. So you check your model summary. And now we're going to fit and train the model. History equals model.fit, train features, train labels. So that's your train data set. Validation data equals val features, val labels. Verbose equals 0 because I didn't want to see it. And epochs equals 100. And then so it finished the training. So now we're going to make predictions. So test predictions equals model.predict, test features dot flattened. Test predictions. So if test predictions are less than 0, it's going to just be a 0. And then we made a graph, and then we graphed our predictions out against our actual values, and that doesn't look fantastic, but what can you do? Now what we're going to do is we're going to calculate the RMSE, which is the root mean squared error, and you get an RMSE of 14. And then now we're going to compare our actual values to the predicted values. So you can look at your actual values and predicted values and see how they stack up. So this data set wasn't fantastic. Another thing that we could have done, which we didn't do, is we could have made a heat map. And that would have told you how highly correlated the columns were. I don't know if the heat map's going to be very good with one hot encoding, but we can do this. We can try this. And then another thing we'll do is we'll do core. So we'll try it again. I hope it works. It worked before, so I hope it works again. And obviously I'm still learning TensorFlow, still learning how to do things the TensorFlow way. And they use the formulas and functions in TensorFlow a little bit more differently than they do them in sklearn. And normally I would just type in the code to normalize my data automatically, but you might not have, you want to make sure that the data is normalized within the model. So here we've got our heat map, and so you can see most of the values have a low correlation except for temp, ISI, DC, and DMS. Those have a pretty high correlation. But you don't have anything that's got like a 1, like 95% or anything like that. And then so you do your core, and your core gives you the correlation, tells you how highly correlated everything is. And it looks like I made a mistake. Looks like it failed to work somewhere. So let's see what's happened. Val labels, val predictions. Test. So there we go. It did we had to use test and not val, so that's what the problem was. So there you go. So we did get it to work in the end. And so I've done everything that I could do. I did a little bit more than I would have done because I think that on TensorFlow, they're not very good on exploratory data analysis. So I put in a lot of charts that actually weren't in the actual TensorFlow code because I wanted to do an exploratory data analysis with that as well. So since I've been talking 20 minutes, I'll go ahead and conclude this code review. I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you so much for watching my code review. I look forward to making more code reviews